Everyone
Hello,
has joined.
sir.
Hello. Kavalia,
Yes,
are you facing some internet issue, Kavalia? Because everyone is able
yes,
to hear me, and I received your message that you were not able to hear me.
yes. Now also that is happening. Little bit.
Okay, then do one thing. Mute your mic and yeah, do not switch on your videos at all. Otherwise, it will consume more bandwidth. Then the network will probably be more slow. So we can proceed ahead.
Yes,
Everyone give a thumbs up on your screen if you want me to go ahead with the class. Okay, so we'll go ahead then. I will share my screen. You can see my screen, right? Okay, let me minimize it. Where did I stop? Okay, guys, I am going ahead with the class. If you have any concern, unmute your mic and ask me, okay? So I said that the carbon compounds having a double or triple bond between two carbon atoms. Always remember this part. Only between two carbon atoms, if they are having double or triple bond, they will be called unsaturated compounds. Now let's see what ethene and ethine are unsaturated hydrocarbons, which is correct, right? Let me show you the structure of ethene. You can see my screen, right? Can you see this?
Yes.
Yeah. So this is the diagram of ethene. If you will see properly, it has two bonds, right? Can you see the two bonds here? Now let's talk about ethine. Okay. Now ethine, it has three bonds. See what it is saying. Google is saying ethine. Can you see three bonds here between carbon and carbon? So ethene and ethine have double and triple bond. That is why they are unsaturated hydrocarbons. Okay. Now the unsaturated hydrocarbons containing a carbon-carbon double bond are called alkenes. It is very important point. Please pay attention. The unsaturated hydrocarbons where carbon-carbon atom have double bond, then it will be called as alkenes. And if the unsaturated hydrocarbons whose structures contains a carbon-carbon triple bond, it will be called alkynes. So what is the difference between alkenes and alkynes? Alkenes will have double bond between carbon atoms. Alkynes will have triple bond between carbon atoms. Okay. Now let's see ahead. Generally, the unsaturated compounds are more reactive than the saturated compounds. Okay. This is a point that is to just like you can simply note it. You can probably keep it in your mind that the unsaturated compounds. What are the unsaturated one? The definition is here. The one where carbon and carbon are having double or triple bond, they will be more reactive than the saturated compounds. So this much is done. Now what are the things that you know? You know what is alkane, where the carbon-carbon is having single bond. What is alkene? Carbon-carbon is having double bond. And what is alkyne? Carbon-carbon is having triple bond. Okay. Similarly, what is saturated compounds? Where carbon-carbon is having single bond. What is unsaturated? Where carbon-carbon is having double or triple bond. It is called unsaturated compounds. Now let's read about straight chains, branch chains, and rings of carbon atoms. So let us see this, what it wants to say. What is this paragraph about? It is saying that let us compare the structural formula of methane, ethane, and propane. From this structural formula, it is seen that carbon atom, single or more carbon atoms bonded to each other, lie in the core of the molecule. What is it trying to say? That in a molecule, like molecule here is referred to methane, that is CH4, ethane, that is C2H6, and propane, that is C3H8. 3 carbons and 8 hydrogens. It is saying that carbon atoms, like single or more carbon atoms, are bonded to each other, right? So it lies in the core of the molecule. It means in all these 3 molecules, carbon will be bonded to the other carbon atom. Now, while the hydrogen atoms bonded to each of the carbon atoms are on the periphery of the molecule. Periphery means at the end of the molecule. Let us understand it in detail. The mutually bonded carbon atoms in the core are like skeleton of the molecule. The carbon skeleton determines the shape of the molecule of a carbon compound. Okay. These things that you have to like just keep in your mind, that the mutually bonded, like mutually bonded means the carbon atoms which are bonded with each other are like the skeleton of the molecule. Now it is not a point that you will like hear anywhere. Let us go ahead. A straight chain of carbon atoms is formed by joining the carbon atoms that are next to other. Okay. Now, since the topic, what is the heading? Straight chain, branch chains, and ring of carbon atoms. So it is saying what is a straight chain? Straight chain is the one where carbon atoms are bonded next to each other. So it is also giving an example of that. The first column in the table 9.12 shows straight chains of carbon atoms. Okay. So let's go to table 9.12. This is table 9.12, right? And they are correct. They have written it correct. This is a straight chain, right? One carbon is bonded with the other, and the other is bonded with the other. And similarly, all of them are bonded to one after each other. They all are bonded in one single line, like a chain, right? So that is why it was called straight chain. Okay. Now, okay, so they are telling us to write the structural formula of the sorry, of the corresponding straight chain hydrocarbons in the second column, satisfying the tetravalency of the carbon. Okay, nothing. What they are telling us is to predict the structural formula. They are telling us, they are giving a task to us that write to us the structural formula in such way that it should satisfy all the tetravalency of carbon atoms. It means all the carbon atoms should have 4 bonds by joining them to hydrogen atoms. Okay, so we'll do that. See, first important thing to understand is, you will see it very proper, like clearly. If you have one carbon atom, you cannot form a chain, right? It will be one single carbon atom only. So how many bonds will you need for hydrogen? Like for carbon to satisfy its valency, you need 4, right? Because none of the other carbon is present. So how will you satisfy those 4 bonds? Using 4 hydrogens. That is why it is called as methane. These are the keywords if you will learn in more detail. Ethane means there are 2 carbon atoms. Propane means there are 3 carbon atoms. Butane means there are 4 carbon atoms. Pentane means there are 5 carbon atoms. Hexane means there are 6 carbon atoms. Heptane means there are 7 carbon atoms. Octane means there are 8 carbon atoms. Nonane means there are 9 carbon atoms. See, 1, 2, 3, 4, 5, 6, 7, 8, 9. And similarly, decane means there are 10 carbon atoms. So if you get this name, you should at least be able to find out how many carbon atoms they should have. So you have to memorize this. Methane will have 1, ethane will have 2, propane will have 3, butane will have 4. So this is what they are trying to say. Now let's see uh, how to satisfy their molecular formula. Like here we need 4 hydrogen, right? So how many hydrogen we'll need in this case? If you will look carefully on this both are having 1 bond, right? They need 3 hydrogen atoms on each of them. So how many total hydrogen is required?
6.
Very good, excellent, excellent, Jonisa. So what will be the molecular formula? It will become C2H6. Excellent. Now if you will notice, there are 3 carbon atoms. Now this carbon atom is at end, right? It has only 1 bond. This carbon atom is also at end. It has only 1 bond. So these two will need 3 hydrogen atoms to satisfy their valency. And this carbon atom already has 2 bonds with the other carbon atoms, right? So this will need only 2 hydrogen. So if you will see, this one will need 3, this one will need 2, that is 5. This one will need 3, that is 8. Am I correct? So the molecular formula will become C3H8. Okay. C3H8 for propane. So similarly, the series will go, and then you have to find it out. Okay, let me ask to someone. Wait, who is there? Ryan, can you hear me? Ryan,
Yes,
tell,
sir.
tell me how many hydrogens are required in butane? You can see butane here, right?
Yes.
Tell me how many hydrogen atoms will be required for the carbons to fulfill their valency?
10.
Okay, how did you find it out?
First carbon had only one bond.
Sorry.
Every carbon,
Yeah, okay, yeah, go ahead.
and second carbon have two bonds, and third also have two bounds, and last one had one bond.
Okay,
And first one carbon need four hydrogen bound.
so it needs 4 bonds, but it
Four
already has
bonds,
one bond, so it will need
one
only
bond.
3 hydrogen, right?
Yes,
Then this one will need how much hydrogen? Second one?
two,
Very good. This one?
two,
Very good.
and
So
last
3
one
plus 2, 5, 5 plus 2, 7. And how much will be needed by this one?
three,
So total is 10, right?
10.
Very good, very good. Mutual partner, very good. Now let me call Lean. Lean, can you hear me? Lean? I don't know what is this. Prachiti, can you hear me?
Yes.
Hello.
Yes, sir.
Okay, Prachiti, tell me how many hydrogen are required for pentane. You know, it has 5 carbon atoms. So the molecular formula is pentane.
Yes.
How many hydrogen is required?
12.
Very good. Why? Because this will need 3, 3 plus 2, 5, 5 plus 2, 7, 7 plus 2,
7.
9, and this will need
9.
3 more, so it will become 12. Very good, very good.
Yeah.
Very good, excellent. So similarly, you can find it out the molecular formula, right? And once you find a molecular formula, a structural formula to draw is very simple. You will simply add every carbon atom with the other one with single bond. See, it is about C4. There are 4 carbon atoms, right? And hydrogen is 10. If you will see, this all carbon atoms here are bonded with each other, a single bond, right? They are all are singly bonded with each other. And this one has 3 hydrogen, 2, 2, and 3. So this has total 10 hydrogens. That is why, like if you will see properly, since they are having single bond, it is the structure of butane, right? Butane. Okay. Now see, it is saying that with the help of 4 carbon atoms, I can either have a chain like this, like a molecule like this, or I can have like this also, right? Here, the center carbon is linked with the other 3 carbons by single bond. So this carbon will need 3 hydrogen, this will need 3 hydrogen, this will need 3 hydrogen. But this carbon needs only 1 hydrogen. So total will be again 10. So that is what it is said, you know, that there are multiple chains which can be formed with the same molecular formula. And this is what is isomerism. I remember in the YouTube video I was talking about it, and I told you that I will explain you later. So isomerism means with the same molecular formula, like the molecular formula will be same, but the molecules will be different. If you say this is a straight chain, right? This is not a straight chain. This is branched because it has branches. Guys, did you understand this? Okay, 1 second. Wait, I have to check how many of you understood this. So those who have understood, please give thumbs up. Thumbs up on the screen, those who have understood. Okay, everyone understood, great. So, okay, so let's go ahead. I will share my screen again. And yeah, Now let us read in detail. So two different structural formula are obtained on joining hydrogen atoms to these two chains so as to satisfy the tetravalency of the carbon atoms. Satisfy the tetravalency. Yeah, words looks like it is very scientific, but it is very simple. It is saying that carbon will have 4 bonds. Okay, so it is saying that the molecular formula of both this structural formula, like this both molecule, have the same molecular formula. They are having 4 carbon and 10 hydrogen, but their structures are different. So there are two different compound as their structural formula are different. Yeah, it is correct. So the phenomenon, now it is very important line, highlight it. The phenomenon in which compounds having different structural formula have the same molecular formula is called structural isomerism. Very important point. The phenomenon in which compounds having different structural formula have the same molecular formula, because the molecular formula is same for both of them, right? This also has 4 carbon, this also has 4 carbon, this also has 10 hydrogen, this also has 10 hydrogen, but their structures are different. And if the structures are different and molecular formula is same, it means they are structural isomerism. Now, number of carbon compounds increases further due to isomerism observed in carbon compounds. The carbon chain 1, like it is talking about this diagram. If you will see in the figure 9.13a is a straight chain, right? The chain is straight. There is no branching. But the second diagram is having branching. So it is a branch chain. So this is the thing that we have to understand. Let's go ahead. Apart from the straight chain and branch chains, closed chains are also formed. Okay. So closed chains of carbon atoms are present in some carbon compounds, wherein rings of carbon atoms form. If you will see this molecule, if you will see this propyl, it is called cyclohexane. Cyclo, why? Because it is cyclic, closed chain. Why hexane? Hexane, hex, because it is having 6 carbon atoms, and N is derived from alkane. Alkane means single bonded atoms. So that is why this one is called as cyclohexane. So let us study further. It is saying that apart from the straight chains and branch chains, closed chains of carbon atoms are present in some carbon compounds, wherein rings of carbon atoms form. Okay, so the ring is formed. Now, here is the diagram of C6H12. C6 and H12. And it is saying that the structural formula contains a ring of 6 carbon atoms. Now you see this molecule. This molecule, like this is simple representation. Don't think that carbon is not having 4 bonds here. That is why they have drawn this diagram here to make you understand that carbon will always have 4 bonds, no matter what. If you will see, this carbon has 4 bonds, 2 with the hydrogen, 2 with the carbon itself. This carbon also has 4 bonds, 2 with the hydrogen, 2 with the carbon itself. Every carbon here, they have 4 bonds each. But the thing is, it is called cyclohexane because it is forming a cyclic structure. Now we will read in detail about the ring structure of cyclohexane. Okay. Before that, let us see some important thing. Very important, right? I told you saturated and unsaturated. If you will see the diagram of unsaturated, it will have double bond, triple bond, double bond, triple bond. This is the all. These all are the categories of saturated. See, it also in cyclohexane, hexene. Be careful with the name. Cyclohexene also has double bond. Okay, and but if you will talk about hydrocarbons, saturated, each of the carbon are bonded to each other with single bond only. No matter if they are straight, no matter if they are branched, or no matter if they are cyclic, but each of the carbon atoms are bonded with each other with the single bond. And that is why they come in the category of saturated. If any of the carbon is bonded with other with double or triple bond, double or triple bond, it will come in the category of unsaturated hydrocarbons. Okay, everyone understood?
Yes.
Okay, so I have one question I will ask to Kajal. Can you hear me? Tell me, what is the difference between saturated hydrocarbon and unsaturated hydrocarbon?
Yes.
Hmm? Kajal? Tell me the difference between saturated and unsaturated hydrocarbon. I just said, right? Okay, let me ask to someone else. Jules, can you hear me? Okay, can someone wants to answer this question? Someone wants to answer this question on their own? Like, okay, sir, I know the answer. I want to answer this. Difference between saturated and unsaturated hydrocarbons. Okay, Johnny, sir, what about you? Do you know the answer?
No.
Johnny, sir, very simple. I explained you before this class that saturated hydrocarbons will have single bonded carbon atoms. Unsaturated hydrocarbons will have double or triple bonded carbo atoms. Understood? Let's go ahead then. It is learned from the structural formula of benzene that it is a cyclic unsaturated hydrocarbon. There are three alternate double bonds in the six-member ring structure of benzene. The compound having this characteristic unit in the structure are called aromatic compounds. Okay, this is they're talking about this. Okay, they are saying that this molecular formula, like common name is benzene, and molecular formula is C6H6. This is the structural representation. If you will see, alternatively, every carbon atom is bonded with the other one, like I can say alternate series, like they are bonded with double bond, then with single bond, then with double bond, then with single bond, right? So this kind of characteristic are like the compounds, the molecules which have this kind of characteristic are called aromatic compounds. Definition of aromatic compounds can be asked. Okay, now let's go ahead on functional groups in carbon compounds. So it is saying that till now you have learned about the hydrocarbon compounds formed by combination of the elements carbon and hydrogen. Okay, many more types of carbon compounds are found by formation of bonds of carbon with other elements such as halogens, oxygen, nitrogen, and sulfur. Okay, it is saying that other atoms like uh, halogens or oxygen or nitrogen or sulfur also make bond with carbon and they form new molecule. Let us read about it. So it is saying that the atoms of this element substitute one or more hydrogen atoms. Substitute means they remove one or more hydrogen atoms and in the hydrocarbon chain and like they replace them the hydrogen atom by themselves, and in the same way they are also satisfying the tetravalency of carbon. That is the rule that carbon will have four bond. The atom of the element which is substitute for hydrogen is referred to as heteroatom. Heteroatom means like the element which comes at the place of hydrogen is called as heteroatom. Hetero means different, right? More different than carbon and hydrogen. Sometimes heteroatoms are not alone, but exist in the form of certain groups of atoms. Okay, we'll read it in detail. It is saying that compound acquire specific chemical properties due to these heteroatoms or the group of atoms that contain heteroatoms, irrespective of the length and nature of the carbon chain in the compound. Therefore, these heteroatoms or the group of atoms containing heteroatoms are called functional group. Okay, let us understand this with the help of table. See, these all are heteroatoms. Heteroatoms means atoms different than carbon and hydrogen. So halogen is there. Inside halogen, if you remember, in periodic table, we had group number 17, which was called halogen group. Elements inside those group were fluorine, chlorine, bromine, iodine, right? So the same names are given here, and they have given some name, halo, that is chromo, bromo, iodine. If oxygen is there, it can form alcohol, it can form aldehyde, it can form ketone, it can form carboxylic acid, it can form ether, it can form ester. Now let us see how. If the oxygen is present as OH, it will form alcohol. With carbon, it has this group. This is a group. It has to present with the carbon. अगर कार्बन की किसी बॉन्ड से एक ऐसा ग्रुप लगा हुआ है या अटैच्ड है, it means that is an alcohol. But if the same carbon, like the carbon is here, and oxygen is double bonded with carbon, and hydrogen is also bonded, it means we are talking about aldehyde group. Okay, it can be simply written as CHO. Alcohol can be simply written as OH. This can be written as CHO. And then we are talking about ketone. In ketone, if you will see, there will be no hydrogen. Okay, here also carbon, here also carbon, like this. So it will be written as CO. Carboxylic acid, if you will notice very carefully, it has OH and also double O. So if a carbon atom is having double O, that is double bonded oxygen, and OH group attached to it, it means it is an acid. What about ether? Very simple. In ether, both the sides will be carbon. And ester, both the sides will be oxygen, but instead of hydrogen, like we have hydrogen in carboxylic acid, here we will have some other carbon. Okay, simple to understand. And nitrogen, very simple, they are called amines and they will have an HH. Here maybe some carbon atom, and this group will be linked or bonded with the carbon atom that is present at the last. So these are the some functional group in carbon compounds. Okay, how many of you have any doubt in this? Please ask me. Any doubts in this? Please ask me.
No.
No doubt. Okay, that is fine. Anyone else? Anyone else wants to ask anything or you don't understand anything? Okay, Siona, can you hear me?
Yes, sir.
Siona, tell me the difference between saturated hydrocarbons and unsaturated hydrocarbons.
Unsaturated have more hydrocarbons and saturated have only less carbon. Hydrocarbon.
No. Okay, let me ask you someone else. Carol, can you hear me? Okay. Swaroop, can you hear me? Okay. Janisa, would you like to answer this question now?
Yes.
Sir, I will answer.
Yeah, okay, answer please.
Sir, saturated is having only one bond and unsaturated is having two or three bonds.
Very good, excellent. Good answer. Thank you for answering that. Thank you, Janisa, also. So let's go ahead then. You have to remember these groups, इसको याद करना पड़ेगा. It is very helpful and it will, if you will not remember this, you will probably do a lot of mistakes in exams. So remember these groups. If it is OH, it is alcohol, CHO, aldehyde, all this. Let's go to homologous series, okay? So it is saying that what is homologous series? Let us understand it then. You have seen that chains of different length are formed by joining the carbon atoms to each other. Yeah, we have seen that. Moreover, you have also seen that a functional group can take place of a hydrogen atom on this chain. Yeah, it is written here, right? My carbon, it is attached with one oxygen. Instead of attaching with hydrogen, it means the functional group. What is functional group? When some other elements substitute at the place of hydrogen. So, as a result of this, large number of compounds are formed having the same functional group but different lengths of carbon and chain. Okay. For example, there are many compounds such as, someone texted, sir, now coming internet problem. Okay. So such as CH3OH, then CH3, CH2OH, then CH3, CH2, CH2OH. So these all are having OH group, if you will notice. So these all have alcohol basically as the functional group. So, so the length of carbon chains in them is different because this one is having one carbon, this one is having two carbon, this one is having three carbons. So it is saying that even length of carbon chain is different. Their chemical properties will be very same because they have same functional group instead of hydrogen, right? So this series is called homologous series. You know, when there is same functional group, but the number of carbon chains are sequentially increasing, the length of carbon chain is increasing. In that case, it will be called a homologous series. There are different homologous series in accordance with the functional group. For example, homologous series of alcohols, correct. We have seen it here, right? One carbon atom, OH group. Here, if you will see, two carbon atom, OH group. I don't know what is this happening. Okay, let's go ahead then. It is saying that the series of compound formed by joining the same functional group in the place of particular hydrogen atom on the chains having sequentially increasing length is called homologous series. Very important point, please highlight it. So this is not the only place, you know, like we can have homologous series of alcohols, or we can have it of carboxylic acid. We can also have of aldehyde and all. So this is the thing that we need to understand, that homologous series is not only constant to alcohol. It can be with any other elements. And what will be the difference? Sequentially increasing length of carbon atoms. But the functional group will be same. In that case, it will be called a homologous series. Now let's go ahead and see what is there. Okay, this is the structural formula of methane. Very simple. If you will understand, number of carbon atom is 1. If it is ethane, number of carbon atom is 2. If it is propane, number of carbon atom is 3. Similarly here, similarly here, C1 carbon atom, C2 that is 2 carbon atom, C3 that is 3 carbon atom, C4 that is 4 carbon atom. And if you will see, each of the carbon atoms will have 4 valency. You have to draw and you have to see, then you will understand this. So this is about alkanes. Why I'm calling alkanes? Because they are singly bonded. None of the carbons are bonded with double or triple bond. Each of the carbon atoms are bonded with single bond only. That is why it is called singly bonded, and that is why this is a part of alkanes. When we are talking about a homologous series of alcohol means it will only have alcohol, and homologous why? Maybe because the carbon number is increasing. So similarly here, CH3OH, one carbon and one OH group, so alcohol. Now CH4 is actually methane, right? So since there is one carbon, we have added the suffix name all, methanol. Whenever there will be an OH group जब भी रहेगा तो कॉमन नेम के पीछे ऑल लग जाएगा अपने आप. जैसे ईथेन है, अगर तुम ध्यान से देखो, इट इज ईथेन, राइट? C2H6. There are two carbon, 6 hydrogen, and the carbon is bonded with single bond. So it will be ethane, but there is an OH group, so it will become ethanol. Similarly, when there are 3 carbon and 1 OH group, it will become propanol. There are 4 carbon, and if you will see 1 OH group, it will become butanol. So whenever you will have OH group, the suffix all will always be there. Okay. But okay, now let us learn about alkenes. Alkenes also have their homologous series. As I said, alkenes means carbon-carbon having double bond. If you will see, this carbon is bonded with double bond to this carbon. This carbon is again bonded with double bond to this carbon. This carbon is again bonded with double bond, like in this carbon also has double bond. So since these molecules, that is ethene, propene, what is ethene? Because it has 2 carbons, so it. But it is not an alkane. It is not an alkane. Alkane has single bond. Alkane will have double bond, so it becomes ethene. Similarly, about butene, you know, one butene. One butene means the double bond. This one is nothing but the name of the, or like the position of the double bond. So if you will start marking this, we will start it from right to left. So that is why we have given 1. Like you can actually mark from left to right also, but you will have to see where is your double bond. If your double bond is like जिस साइड से क्लोज पड़ रहा है डबल बॉन्ड, उस साइड से काउंटिंग चालू करो. तो यहाँ पे तो फर्स्ट नंबर पे पड़ रहा है, तो मैंने यहाँ से चालू किया, तो मैंने 1 butene लिख दिया. If you will notice here, I have 5 carbon atoms here, but it has double bond. So 5 carbon atoms will bring them in pent, and if they would be having single bond, it will become pentane. But since it is having double bond, it will become pentene. Okay. Okay, let me ask how many of you understood this. How many of you understood this? Please give a thumbs up. Okay, good. How many of you understood this? Please give a thumbs up. If you have any doubt, you can unmute your mic and ask. Don't feel shy, you know. Shyness will not come to right in your exams and score you and probably provide you a better marks, which I think everyone needs. If you have any doubt, please ask me. No one has any doubt, right? Okay. Come back to online class. Yeah, you are in the online classroom. So for now, I think, yeah, I will stop till here. With the number of carbon atoms. And let's see how many more are remaining. Okay, still there are many things left. We'll complete it in the next class. So guys, unmute your mic and switch on your videos, please. Lisa, did you understand everything I taught today?
Yes, sir.
Huh? Okay, what about you, Prerna? You are laughing.
Yes. Yes, sir.
Did you understand whatever I have taught you today? Hydrocarbons, saturated, unsaturated, alkanes, alkenes, alkynes. Understood everything?
Yes, sir.
Okay, what I will do is ये जो क्लास मैंने लिया उसका एक ट्यूटोरियल मतलब इसका रिकॉर्डिंग भी है मेरे पास वो मैं अपलोड कर दूंगा यूट्यूब पे और मैं लिंक भेज दूंगा क्लासरूम में ओके सो इन केस इफ समवन मिस्ड आउट और इफ यू वांट टू रिवाइज सम कॉन्सेप्ट you can revise it from there. Okay, guys? Okay. Ryan, you understood everything, right? Ryan, did you understand everything?
Yes, sir.
Okay. What about Chris? Chris, did you understand everything?
Yes.
Okay, great. Janissa got everything, right? No doubts. Okay, so today's class I will end here. Don't worry. We will meet tomorrow. This week we will have very frequent classes. इस वीक मैं तुम्हारे अच्छे से क्लासेस लेने वाला हूँ टाइमिंग थोड़ा चेंज हो सकता है समटाइम्स इट विल बी एट 2 p.m. or at 5 p.m. but yeah you will be having very frequent classes this week. Okay guys, so whatever I have taught you today I will upload it on YouTube. I will send the link. Please revise it and try to solve the questions which you can. Try to understand, read the textbook, make short notes, and yeah, that's it. Thank you for joining. We will meet tomorrow at 2 p.m. again. Bye. Bye everyone. Bye bye. You can leave the class.
sir.
Bye Kaval. Kaval, I will upload this in the YouTube video. Don't worry. So you will understand it better. You know, you can download the video there. Okay.
Okay.
Bye everyone. Bye.
Bye.